Have you ever noticed how a website can look crisp on some screens but blurry or pixelated on others? If you have watched our previous video on media queries, you'll remember we used media queries to adjust layouts for different screen sizes. Today we are tackling a different issue, making sure your background images stay sharp and clear even on high DPI and large screens. If you've ever used a high DPI screen like Retina display, you may have seen the same background image appear blurry or pixelated even though it looks fine on other devices. Let's break this down why this happens and how to fix it. Before diving into the solution, let's quickly define a few key terms, DPI and PPI. DPI stands for dots per inch and refers to the number of dots or pixels that fit into a single inch of a printed image. Meanwhile, PPI stands for pixels per inch, which measures pixel density on digital screens like your smartphone or laptop monitor. The higher the PPI or DPI, the more pixels are packed into each inch of the screen or print, making images sharper and more detailed. A regular screen is nearly 100 PPI to begin with, but Retina display, a high DPI screen commonly found on Apple devices, has a very high PPI, often 300 pixels per inch or higher. This means it can display much sharper images compared to regular displays. So, what does this mean for your website's background images? When using background images, many websites default to using a single image resolution, regardless of the screen's DPI or PPI. On a regular screen, this may not be an issue because the image is sharp enough for the standard pixel density. On a higher DPI display, the screen has more pixels packed into each inch, but if your image isn't high enough resolution to match that increased pixel density, it ends up getting stretched and looking blurry or pixelated. This is especially noticeable for background images that are stretched across larger areas of the screen. The result, your beautifully designed website will look great on some devices, but blurry and unprofessional on others. Alright, so let's head over to Visual Studio Code and see the problem firsthand. In this example, we are using a relatively small image as the background, which is this small variant of the VG large image that we have been using. So it's a 64 by 48 pixel image now. And on regular screen, it may look just fine, but on high DPI devices like a Retina display, the image will appear pixelated because it's being stretched too far. In fact, since we are simulating the problem, a 64 by 48 pixel is already pixelated and blurry on our relatively small viewport on this monitor. So how do we fix this? The solution is simple. We need to use high resolution images for high DPI devices. By detecting devices with higher pixel density, we can serve images that are large enough to look sharp and clear even on Retina displays. All right, so let me introduce you to bunch of variants I have created for this PG large image. So the original one is 1024 by 768 pixels, but then I have variants for 64 by 48, twice as big, 128 by 96, 256 by 192, and 512 by 384. So we are going to use this. So I'm going to make some code modifications. Hang along. I'm going to fast forward from here. Okay, here's the final code. And now we have three or rather four layers of background images. The first one, BG large 64 by 48 is the standard one. Then we have 128 by 96, which is applicable if the resolution is 130 pixels or higher. And then we have rules for 250 pixels and 500 pixels. So rather than explaining these one by one, you can see the results. So just keep an eye on the image and look at it suddenly gets sharper and it's getting larger, 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 and then it gets swept by the next variant. See, this is how you target multiple screen widths using a single CSS file. And yeah, the final one, this min width 1200 pixel means that if the screen width is 1200 pixels or more, then the largest image, which was our 1024 by 768 image, would be applicable for all screen sizes 1200 pixels or more. To implement the next phase of enhancement to our CSS, a brief overview of some key concepts like CSS pixel and physical pixel is necessary. A physical pixel is the smallest unit or dot on the typical screen. A CSS pixel, however, is a logical unit of measure used in CSS, which you refer to, say, in defining width and height. The logical pixel corresponds to a standard web reference where 96 CSS pixels are supposed to occupy 1 inch. So when you say define width 96 pixel in CSS, you're asking CSS to occupy 1 inch of a standard screen. And normal or standard screens are just that, 96 pixels per inch, where one CSS pixel corresponds to 1 pixel on screen and 1 inch contains 96 pixels. But of course, the world has moved ahead, and today's high DPI screens pack many more pixels than the standard definition. Though that high number is generally somewhere in the middle, we typically target multiples of pixels per inch in our media queries to take appropriate actions. Before we do that, just note that a 2x display means 192 pixels per inch and 3x display has 288 pixels per inch. And of course, 1x is the standard 96 PPI, which remains the same from CSS perspective. So let's go over an example. So say our user opens browser on a screen with 3x pixel density, and we had designed maximum for users using 24 inches screen, which would be around 20 inches wide, such that our background image would occupy the full width of the screen without any distortion or pixelation. For that, we calculated that our image needs to be of resolution 1920 by 1080 pixels. How? 20 times 96 is 1920, and we assumed a 16 to 9 aspect ratio, giving us height of 1080. On such standard display, our background image would cover the entire width without distortion or pixelation. But our user was using a retina display with 3x pixel density, so his 24-inch monitor would be 5760 pixels wide, and hence our supposedly high resolution image would barely cover a third of his screen, or would be stretched to cover, in which case we would be showing one image pixel in space of three physical pixels, resulting in a pixelated or blurry image effect. To handle such cases, we need to detect if we are in world of retina screens using media queries and provide appropriate images to handle such situations. And so let me type the next media query. Let me fast forward from here and then I'll explain. Okay, so what did we do here? We have defined a media query which is targeting WebKit min device pixel ratio 2, which essentially means if we detect that the user is using a 2x or 192 DPI screen, then use this background image, which would be twice as big as standard image which we intend to use for our 1x displays. And similarly, the next query is exactly the same for targeting 3x. And this is another way of writing media query where we say min resolution is 288 dpi, and this is exactly the same as this syntax. There is no difference. They are just two different ways of saying the same thing. And this is the third way of saying the same thing as well. If you wanted to target 2x display screens, then you would say 192 dpi, but for 3x display screens, you are saying 288 dpi, and this comma means or. So either this or that, and both are exactly the same. I'm just introducing you to the syntax. So min resolution 3 DPPX, where DPPX means dots per CSS pixel, three physical dots per CSS pixel. You can assume, and in this case, you are going to use BG3X, which would be our three times bigger background image, which would be applicable for 3x DPI screens. These media queries should ensure that the images that you are using and what the user is seeing is unpixelated and not a blurry image. Alright, finally, these were the end-level media queries, and I must remind my viewers that in CSS, the order of defining rules matters. So a rule defined at the end can override any rule defined earlier. Coming back to the topic, if you want more control, that is, you want to say provide images for a 3x PPI screen if minimum width is 600 pixels or more, you can absolutely do so, and let me show you how. So this time we used a new syntax for media query, which is involving this AND clause. So you saw that we're using this comma was the OR operation for these two operands. And if you want to use AND, you can just explicitly type AND between both operands. So this media query is going to be applicable if minimum width is 600 pixels and the min resolution is 3 dots per CSS pixel, right? And in this case, you are going to be serving a 3x DPI version of the same image, applicable for 600 pixels or more. You can write others for all variants that you have already written for standard or 1x pixel density. I understand the video is getting longer, but so will your website size if you are not careful with these 2x and 3x variants. So, do remember, while it's important to use high resolution images for clarity, we also need to optimize them for performance because the size increases exponentially. Not exponentially, but high resolution images can be quite large, which can slow down your website's loading time. So, here are a few performance tips. First being, make sure your rules serve high DPI versions only when necessary. Secondly, use modern image formats like WebP or AVIF. These formats offer better compression and quality than older formats like JPEG and PNG, and that is applicable across the board. So also applicable for 1x images. There's also an option to lazy load images, which is generally associated with normal images, not background images, but there are a few ways to do so. I apologize, we can't go in details of how to do that here, but you can look it up. There are specialized libraries to do so. And finally, you can compress images to reduce their file size without sacrificing quality. And that brings us to end of the video. By serving high resolution images based on device DPI, we can make sure your background images stay sharp across all screens, whether your users are on desktops, laptops, or mobile devices, or retina screens. This approach ensures a crisp, polished experience for everyone. Lastly, thanks for watching. Don't forget to like, subscribe, and hit the bell icon for more web design tips. See you in the next video.